No discussion about chemical reactions is really complete without mentioning solvents. Just about all chemical reactions, when they're performed on purpose by humans, are performed in the aqueous, I should say the liquid phase. They use a solvent. There's good reasons for that. They're not typically done in the solid phase. They're not typically done in the gaseous phase. They're most commonly done in the liquid phase. We'll also take a brief look at acids and bases, mostly because we just haven't mentioned them and we're already like up to Unit 8 here. This is Screencast 8.5. Okay, solvents, acids, and bases. Here's 3 reasons that solvents are your friend. Another way of saying this is, here's why solvents are used so often for chemical reaction. They speed up a reaction by many orders of magnitude. The reason is when something dissolves, every single particle, molecules or be they elements, gets separated, right? It doesn't break any chemical bonds, so water's still water, but it might break up, it will break them up into individual molecules. That's a big deal. I mean, compare, sodium chloride as one big block compared to in solution, not only breaking up every single sodium chloride compound, but also breaking it up into individual ions. The difference in surface area is immense. They absorb heat, which can be handy, and they transfer easily. A little bit more about absorbing heat. Say you want to do a reaction at 78 degrees Celsius. You might choose to use ethanol as your solvent and then simply heat it up to its boiling point. You could set the hot plate to 200. It'll still, set the hot plate to high. It'll still just go up to 78 and boil. If you add a condenser to it, it will reflux and will do that essentially infinitely, so you can choose your temperature wisely. Ethanol might not be a great choice as a solvent because it could be reactive. However, they can absorb heat and they can dial in the temperature of the reaction. They transfer very easily, and robotic systems take advantage of that. I've seen robotic systems for solids, and they're just horrible, trying to weigh out stuff as a solid and transfer it. Yuck. But if it's a dissolved liquid, that solution just can get pipetted up 96 at a time, for example, and you can perform reactions combinatorially, meaning, in great numbers, very easily. Hey, some common acids. How about hydrochloric, HCl? Acetic, can you think of any others? Nitric? Nope. Sulfuric, H2SO4. That's a nasty one. Nitric, oh my god, that can dissolve metals. And some common bases. They all end with hydroxide. Notice that the acids typically start with H. They all have what they call an acidic proton, an acidic H. In this case, it happens to be at the end. Sodium hydroxide, lithium hydroxide, magnesium hydroxide. Don't forget to balance them out. Magnesium is +2. Hydroxides are all -1. You might be getting to see that hydroxide is the quintessential form of a base. H+ is the quintessential form of an acid. And that ends our chemical reactions unit. Unit 8 is over.